Hey, I am Mridula Murli. I'm a graduate student at University of South Florida. Today I am going to take the topic airflow. So here I will be covering the introduction series. I'm planning to do an playlist on airflow, and this will be the introduction series of that, and I will be covering more topics later on. So why airflow? So we usually do technologies and write codes to do a specific task like web development or machine learning code, but we usually don't give much attention to the deployment part, how the workflow can be managed. So I will be taking this topic, which is equally important to understand. So what is Airflow? An Airflow is an open source management platform which can help us to analyze and see the pipelines and how the data is managed. And this was developed by Airbnb in October, and later it was took by the Apache Software Foundation project. This was an open source project, and now this is one of the main project of the Apache software. And why are we doing this? Like why we need airflow? So usually doing and managing this task, this data pipeline is very cumbersome, and going through this task and to see the log, to see the like task instance, to see the logs, how they run, like whether they are success or fail, doing that is very difficult. But if we can do that with code, that will be very helpful, and that is achieved with the airflow. And the airflow is written in Python, and the workflows are created via Python scripts. So how does the airflow work? Airflow uses DAGs to manage this workflow, which is directed acyclic graph. So that is a basic component of an airflow. So which are some of the domains that are currently using airflow? And we can see here like data warehousing, search ranking, data export, and many much more domains can use this airflow to manage their workflow. So let's go into deep into the concepts of airflow. So these are some of the main and basic concepts of airflow. So first we can look at the DAG itself, which we mentioned earlier. So DAG is an directed acyclic graph. It is a basic unit of airflow which is built up of many number of tasks to define how the execution is done. So we can see the UI here. So this is the UI of an airflow. So we can see here, these are different DAGs. We can see here like hello world DAG, Docker. So let's click one of it. So here is the graph view of a DAG, and we can see here certain boxes. So these are the tasks, and this whole set is a DAG, and we have individual diagrams. So here if we look at, so let's look at the other one, because I haven't run the other one. So here if you look, this is one of the DAG, and here if you look at the run, I have run like around 3 times. So each run is a DAG run. So we have a DAG, and each instance of that run is a DAG run. And then we have so let's take this symbol. So I'm taking this one. Okay, so this is a hello world tag which I have created, and here we can see we have this individual task. So this DAG are built up of task, and in this task is built up of operator. So what is an operator? So there are many types of operators such as Python operator, bash operator, big bash operator. Then we have email operator. So what is this operator? So operator is used to do a certain task. For example, if we want to transfer a file from one location to the other location, how can we do that? We can do that with a bash operator, which can take the file from one location to the other location, and that will be defined inside this task. So each task is defined with a task instance. And see, for example, these are the different task instances that we are seeing here. So this is a task, and if it runs successfully, we will get that in dark green color, showing that it ran successfully. And if it is a running state, we can see that in light green color, that it is still running. And if this task failed, we can see that in dark red color, that it failed. So this helps us to see the flow and the status of our task. So we covered that here. We saw the DAG, which was the individual tags we have created, and then each execution of a DAG is a DAG run. Then we have a task. Each component inside a DAG is a task, which are also then defined by operators, which does a certain work, like the transfer of a file or like email. All those can be done with the help of operators. And then we have a task instance, which shows us the state of a task, like whether it is a running state or it is success, failed, or that we can see that inside a task instance. Hope that is clear, the Airflow concepts and overview of the UI. So what is the concept of a DAG? So here we can see there are certain nodes here like A, B, C, and these are connected by certain arrows, and these are called edges. So we can see here like this, A is going to the B and then B is going to the C. So it is showing us how the workflow is managed here. So this is not any cyclic, it is acyclic. So it follows certain order. So for what are these nodes doing? So for example, we want to transfer a file from one location to other. So that will be done here. And when this is completed successfully, then only the next node will be run. So once this is run, it will go to here, it will come to B, and maybe the task of B is to clean the data. So once we have the file in our destination location, we can take that file and the node B will take that and clean the data and put in some other location. And then this B will take that data, and once a task is run, then it will go to C. So only once the B is completed, then C will take that, and maybe it will remove certain duplicates. So it follows certain order, and we can see that here like how this is working. So these are the nodes and these are the edges, and it is DAG is defined by this concept of edges and nodes. So one of the main concept of ETL is idempotency. What is idempotency? Idempotency means that however times we run or we try to run a DAG, it should produce the same result again and again. Irrespective of the number of tries, the output should be the same. So that concept is very important in ETL, and the Airflow helps to achieve the idempotency, as we can see here. Then let's go to the main components of Airflow. So the four main core components of the Airflow are web server, scheduler, executor, and metadata database. So web server is the UI that we saw before. So the web server hosts the UI which the user can do the interface with, the user can see the interface. And then we have the scheduler. The scheduler helps to schedule those tasks. So it will be, each task will be, each DAG will be based on certain schedules, like it should run today, like it should run every like Friday. So those can be scheduled, and the scheduler will look at that schedule and run. Then we have the executor. So executor is a part where it will run, it will actually execute, and it will execute with the help of worker nodes. And then we have the metadata database where everything will be stored. So the scheduler will be taking the data from the metadata database. It will retrieve from metadata database and update those tasks or DAG. And the web server will also be taking from the metadata database for the visualization for the user interface. So these are the four components: web server, scheduler, executor, and metadata database. So this is the single node architecture of Airflow. So as we saw before, like we have the scheduler, executor, web server, metastore DB, and queuing system. As we can see here, the scheduler will take the data from the metastore DB and based on the scheduling events, and then it will be passed to the executor where it will be run. And here we can see one more component, that is the queuing system. So it have an inbuilt queuing system which will help to run the based on the queue. It can run the DAGs. And then we have the web server which will take the data from the metastore DB to display the DAG, and which will be updated periodically so that we can see in the user interface status of each DAG. So this is the architecture of multi-node. Here we can see there are so here like we have the different executors, and here the executor will be scaled horizontally, and it will run the DAGs will be run parallelly. And here we can see one more thing, that in the queuing system it is using an external third party queue, and mostly here we will be using the RabbitMQ for the management of the worker nodes. And then we have the scheduler, MetaStoreDB and web server as before. So how does this Airflow work? So we first have the scheduler, and the scheduler will take all the DAGs, all the tasks from the DAG folder. So we will be having a DAG folder which will have all the DAGs, and then we will be taking the DAGs from there based on the scheduling events, and the DAGs from the DAGs folder will then be passed by the scheduler based on the scheduling events, like if it should run now or it should run later, and based on this scheduling events it will be stored to the metadata database. And the scheduler will then pull all the task instances, that is it have everything in the metadata database. The scheduler will then take from the metadata database and it will send to the executor, and after it sent to the executor it will be marked as queued state, showing that it have been sent to the executor. And once the executor takes the queued instance from the metadata database, and the worker node will be executing this, and since that is been executed, the queued state will be changed to the running state in the metadata database. And once the tasks are run, the status is updated accordingly, like whether if it is success or failure. Based on that, the task will be updated accordingly in the database. And periodically the data will be taken from the database to the user interface, so that we can see the status of our task run in the UI. I know this concept is little difficult to understand. Please, if there is confusion, please go through the video once more. And next we will go through the installation of Airflow in the next session. So these are some of the references which I have used. Please feel free to go through this reference, and thank you.